Welcome to the office. We want to take a look today at the least common multiple of a collection of numbers. So this is actually pretty fun here because it's something that refers back to content that we already know, right? Least common multiple. We already know what a least common multiple is. We may not remember well how to find one, but we know what the idea is. But we're going to connect this to groups and group theory. So how can we connect it to group theory, right? That's the question. And we'll take a look at an example of this as well. All right, so let R1, R2, all the way up to Rn, right? This collection of numbers, let them be positive integers. Then their least common multiple of LCM there is the positive generator. Oh, generator? What? We're talking about groups. Okay. The least common multiple is the positive generator of the cyclic group of all common multiples of all the Ri, right? That is common multiples of all of them together. So we have some group of integers those integers are divisible by all of the Ri. So let's find the LCM the least common multiple of 12, 15, 14, and 9. And what I'd like to do is I'd like to first take a look at it from the perspective of group theory, and then try to reason how we work through finding that least common multiple in the way that we maybe have in the past. So the least common multiple of these integers is the generator of cyclic group. Now, if it's a cyclic group, that means it's generated by just one element. But what we're saying here is we're looking at the group subgroup that is generated by all of them together: 12, 15, 14, and 9. All right, so we're interested in multiples here. Okay, the group of common multiples. All right, things that these divide. So what's generated by 12, 15, 14, and 9? And that's, I suppose that's not quite right either. We don't want to say it in that way, because if we think of the integers and under addition, then we're actually looking at the greatest common divisor in that particular notation. Cyclic group of numbers divisible by 12, 15, 14, and 9. Call this group or this subgroup H for simplicity in this example. So notice things like 2,520 belong in H. Okay. 2,520 belongs in H. We also have that 7,560 belongs in H. Okay, right? Both of these numbers are divisible by 12, 15, 14, and 9. If I wanted to, I could add them together. And let's see here, 0 plus 0 is 0, 2 plus 6 is 8, 5 plus 5 is 10. So add the 1 here. 1 plus 2 is 3, 3 plus 7 is 10. So 10,080 belongs in H. It also works out that 8,820 belongs in H, right? There's a lot of different numbers that belong in H. How do we find these? Right? What can we do? Well, we could, right? A mistake that a lot of high school students make when they're looking for that least common multiple, they just go ahead and multiply all of those numbers together. If we were to multiply all of those numbers together, we actually get 22,680. 680, which also belongs in H, right? So all of these numbers belong there. So far, multiplying them all gives us the biggest number. That's a huge number, right? Compared to 2,520. So if we're looking for what generates it, we're looking for a smallest number. Okay, we're looking for a smallest number. And we could also take the negatives of each of these, and these belong in the group H because those are divisible by that as well. But when we talk about the generator, we usually take a look at the positive versions. We're looking at the least positive number that divides or that is divisible by each of those things, which I believe, yep, the positive generator, right? There's a negative generator as well, but we consider the positive generator. And then since we're looking for the least positive number in that group, hey, look, that's why it's the least common multiple. Excellent. So how do we find that generator? Well, I'm looking for the smallest number that is divisible by all of the things. So what I do to find that number is I take each of the numbers that I want, right? The 12, the 15, the 14, and the 9, what I want to be divisible by. So I take my 12, I recognize that this is 2 squared times 3. 15 is 3 times 5. 14 here is 2 times 7. And then 9 I can express as 3 squared. So if I'm looking for the least common multiple of these numbers, what I need is I need the smallest number that contains 2 factors of 2 and a factor of 3 because it needs to be divisible by 12. I need the smallest number that contains 1 factor of 3 and 1 factor of 5 because it needs to be divisible by 15. Do I need 2 factors of 3? Oh, yes, I do because of the 9. But do I need 1, 2, 3, 4 factors of 3? Absolutely not, right? If I have 2 factors of 3, then it's certainly divisible by 12. That number is certainly divisible by 15, and then it's certainly divisible by 9. So I'm going to work through my prime values here, my prime numbers. 2, how many 2's do I need? How many factors of 2? Well, it needs to be divisible by 12, which requires 2 factors. That doesn't require any additional. This one only requires 1, and so I need 2, right? Now I know that I can divide by, or that I will expect to eventually be able to divide by 12 because I have the 2 factors of 2 necessary. I'll also be divisible by 14 because it has at least 1 factor of 2. Okay? I also need a factor of 3 because I see a 3 up here, but there's 1 here, there's 1 here, there's 2 here. So I need 2 factors of 3 in order to ensure that I'll be divisible by 9. All right. Next is 5. I need a factor of 5, so that way now I have a factor of 3 and a factor of 5, so I can see that I'm divisible by 15 here. I can also see that I'm officially divisible by 12, having enough factors of 2 and 3. And let's see here, that's the highest number of 5's that appear, so I need a factor of 7 as well to ensure that I'm divisible by 14. So now I can see 2 squared times 3 is 12, so it's divisible by 12. 3 times 5 is 15, so it's divisible by 15. 2 times 7 is 14, so I know that this is divisible by 14. 3 squared is 9, so I know that it contains a factor of 9. So this is also divisible by 9, that is. If I take any factor away, if I take a factor of 2 away, it's no longer divisible by 12. If I take a factor of 3 away, it's no longer divisible by 9. If I take a factor of 5 away, it's no longer divisible by 15. If I take a factor of 7 away, then it's no longer divisible by 14. So I could not have a number with any fewer factors. So I could not find a smaller number. This number, when multiplied together, actually gives us 1,260. And that is the least common multiple. So the group or the subgroup of the integers is generated by 1,260. That is the least common multiple of these numbers. 12, 15, 14, and 9 is the 1,260. Excellent. So again, we have this nice usage of least common multiple that we have talked about in previous courses, right? Hopefully in a high school algebra class, maybe in a college algebra class, you talked about these things, intermediate algebra, that is. So this, what's boxed as prior knowledge, or likely as prior knowledge. And then what's not boxed is just the discussion of how that fits within our conversation in group theory. All right, so we want to take a look at more group theory, right? What we've talked about so far, we've seen it in group theory, but we didn't see how it fits within within our conversation here in this sections, and that's what happens in our next video. So thank you for your time. I'll see you guys again in just a moment for a little bit more on least common multiple and how that fits within direct products.